Good day, class. So this time we'll be discussing about errors and mistakes. Okay, let's first define what is an error. So according to the book of Juni P. Laput, error is defined as the difference between the true value and the measured value of a quantity. It is a deviation of an observation or a calculation from the true value and is often beyond the control of the performing operation. So when we say error, that is, sabi pa nga, the difference between or the deviation between the true value and the measured value. So in all, let's say you try to measure a certain distance, and because of some factors, although you try your best to give an accurate measurement, but due to some factors, medyo may error siyang konti. So meaning hindi siya sakto sa precise measurements. Okay, nakuha nyo? So as an example, let's say you try to measure a distance or the distance between 2 points. Let's say this point to this point, and you are measuring this using a certain instrument. Let's say you are measuring this by tape. And because of some factors, let's say your tape is a bit too long. So that means na kung i-measure mo na siya, that means you will not arrive at the exact measurement. So nakakay error, or you have an error, a small error, because of using an erroneous measuring device. So that means although you try your best to measure this accurately, but because of the error in the device, syempre mali yung lalabas na error. For example, the true measurement of this line is, let's say, this is 5 meters. But because your tape is too long, masyadong mahaba, or medyo na-stretched out yung tape mo, it registered that your measurement is just 4.9 meters. So that means you have an error of 0.1 meter. So that would be your error. That is the deviation from the real measurement. So let's say the real measurement is 5 meters. Anya, medyo nagkulang ka because of your erroneous tape. So that's why naging 4.9 lang yung measurement mo. So that is error. So the common errors in measuring distances are, let's enumerate this. Number 1, tape not standard length. Okay, so yung sinabi ko kanina, it could be too long or too short. So pwedeng too stretched yung tape mo, or in some, or maybe some situations na condense or na contract siya konti, or your tape is too short. Number 2, imperfect alignment of tape. So ano ibig sabihin nito? So example, you are measuring medyo longer distance. Let's say this is let's say 50-meter distance, then you are using a 30-meter tape. So that means you need to cut the tape. That means you need to measure first 30 meters before measuring the rest of the distance, diba? So because of that, there might be some instances na instead of aligning this perfectly, so dapat ganun yung pagka-align mo, because you are breaking the tape, probably yung alignment mo is not accurate, or meaning medyo lumihis ka. So gumanyan ka or gumanyan. So that is a common errors or causes of errors sa surveying. Okay? So that's imperfect alignment of tape. Number 3 is tape not horizontal. So yun. For number 3, tape not horizontal, that means the tape is not perfectly horizontal if you are measuring, let's say, a sloping ground. So supposedly you should measure this horizontal distance. So the tape should be perfectly horizontal, but for some reason it could be na medyo nagsag siyang ganyan, or nag-incline siyang ganyan, or it could be like that. So for example, yung naghawak ng tape dito is just your ka-teammate mo sa group. So let's say you're measuring it like that. Tapos pag ganun pala yung pag-measure ninyo, your intention is to measure it like this, or no, perfect horizontal like this. Okay, number 4, tape not stretched straight. So if the tape is not stretched right, it could sag, di ba? So, for example, you are measuring from this point, from this level to this level. No. Okay. If you are measuring, let's say, you don't need to, for example, the ground is sloping, so you don't need to lay the tape on the ground. So, kung i-stretch mo siya horizontally, because of gravity, it could sag. So, kung hindi mo siya in-stretch ng mabuti, so the sag could cause an error. Then, sunod is imperfection of observation. So, meaning, probably, the tape reads 0.125, then, ang inyong na-record or ang inyong kapag kabasa is 0.126. So that's an error already. Then number 6, variation in temperature, because any material will either contract or expand depending on the temperature. So kung mainit yung panahon, it will expand. If colder yung panahon, that will contract. So ganun din yung sa tape, especially if you're using a steel tape or any other tapes. And number 7, variations in tension. So that is medyo similar or related dito sa number 4. So mag-vary yung tension, meaning yung pagka-stretch mo sa tape, yung in-apply mong tension on the tape to hold the tape. Okay, so that is common errors in measuring distances. Now let us proceed to the next section, which is about mistakes. So, according again to the book of Juni Pilapilaput, mistakes are inaccuracies in measurements which occur because some aspect of surveying operation is performed by the surveyor with carelessness, inattention, poor judgment, and improper execution. So, ito yung mga, sabi pa mga human errors, but actually they are mistakes because of carelessness, nakaka-create tayo ng mga inaccuracies sa ating measurement. So, common mistakes in surveying are, reading the wrong graduation of the tape, which is related dito sa error na sinabi ko. By the way, I intentionally gave an example of 126 and 0.125 because that is too close to a millimeter. Of course, your intention is to give the most accurate reading, diba? Pero it could be that kasi millimeter na to, these are already millimeters, maybe manabasa mo sa 6 or sa 5. Pero you cannot say that that is a mistake because you are not careless with that. Hindi ka naman careless. Meaning you are trying your best to measure it correctly, but yun nga lang, mali yung pagka-measure mo. Yung nabasa mo, probably nasa gitna between 5th millimeter and 6th millimeter. Probably nasa gitna yung measurement, so you judged it as 6 na lang. Anyway, so number 2, omitting a whole length of tape. For example, the measurement supposedly is 2.013. Then, dahil nag-start ka pala sa one side ng tape, so yung na-measure mo doon is 3.013, meaning instead na nag-start ka sa 0 end, let's say, by mistake, you started at 1. So, meaning na omit mo yung whole measure ng tape. 1 meter ng tape. So, that is one. Although, when we say whole measure of tape, for example, you are measuring a very lengthy distance. So, you need to break the tape like a few times. For example, from here to here, that's one tape length. From here to here, another tape length, another tape length. So, kung nagka-mistake ka, one whole tape length na omit mo or di mo nabilang, so that would be already a mistake. So, ang laki na ng nabawas sa measurement mo. Then, of course, transposition of figures. That's why you need to review about significant figures and rounding off. Then, reading scale backward. No, this is not scale. So, this should be scale. So, please correct in your notes. Reading scale backward. So, nabaliktad yung pagkabasa. Misplacing a decimal point. So, for example, 2.0125. 2.015. So, if you have this measurement, then na misplace mo yung decimal point, that would be 20.1. 15 na. So, ang laki na yung ng mistake. Then, number 6, incorrect recording of field notes. So, yung field note, that would be it's like the notebook used by surveyors. That's just a small note niya. Doon mo ilalagay lahat ng entries or data that you got from your surveying activity. So, if mali yung na-record mo sa field notes, then that would be a cause of mistake. And number 7, adding a row or column of numbers incorrectly. So, of course, that's common even in elementary. For example, you are adding 2.015 ulit, then you have 3.001, 3.01, pero yung nasulat mo 3.01, so dito mo siya na-add, so that would be a cause of mistake. Ayan. So there are two types of errors. We have the systematic error and an accidental error. So when I say systematic error, this type of error is one which will always have the same sign and magnitude as long as the field conditions remain constant and unchanged. It is also called a cumulative error. Cumulative meaning it accumulates. Example, if the tape is too long, so you've been using all throughout your survey work, you've been using a tape that is too long. So that means for every measurement mo, for one whole tape length, you are incurring an error. Then you measure again using the same tape, then your error is adding up. Diba? So up to the time na sa paulit-ulit mong ginagamit yung tape, nag-add up yung error mo, pero the same pa rin yung condition, your tape is too long. Diba? Hindi nagbabago yung condition. So, nag-accumulate lang siya, nag-add up lang yung error. Pero dito sa accidental error, these are errors that are, accidental lang. Meaning, at one point, your tape has been too long, then another point, nagsag na naman siya, and the other point naman is kulang yung tension. So, it's either your tape is too long or too short. So, nag-accumulate siya, pero, lang siya, naka-cancel out lang minsan, diba? So these errors are purely accidental in character. The occurrence of such errors are matters of chance as they are likely to be positive or negative and may tend in part to compensate. Okay? So pwedeng ma-cancel out lang siya. For example, at one point the tape is stretched too much, so that would be too long, and at another point the tape is medyo nagsag siya, then that would be ma-compensate lang siya yung kaninang measurement mo na too long. Okay? So that is about the types of errors. Now, for the next section of this lesson, we'll now talk about precision and accuracy. So this time, I'll be using as reference the book of my younger brother, si Juncel. So this is from his Art of Civil Engineering Volume 2nd edition, the book. Okay, precision refers to the degree of consistency of a group of observations. Okay, while accuracy refers to the closeness of a measurement to its true value. Okay, when you say accuracy, this is more related to the error, diba? So the closer you are, or the smaller your error, the more accurate your measurement. Okay, nakuha nyo? The closer your error, or the smaller your error, the more accurate your measurement. While precision naman, this is the closeness of your measurement. So you could be erroneous, meaning yung error, yung measurement mo is erroneous, pero consistently or precise, consistently erroneous. So that's precision. So ito, illustrate natin by these three figures. So the first figure is it's low precision and low accuracy. To be accurate, kailangan bullseye, di ba? That is for accuracy. Dapat close dito para accurate yung tama mo. Pero in this case, malayo siya sa bullseye at the same time katag in Bisaya. So sa ikalawa naman, or the second example, is low accuracy but high in precision. To be accurate, kailangan bullseye ka, di ba? Pero siguro libat yung tama niya nandito. Hindi niya alam yung andito yung andito yung nakita niyang bullseye. So you are not accurate kasi malayo ka, pero you are precise kasi you are tinatamaan mo at consistently at close to 1 point. So you are not precise, or you are precise but you are not accurate. And in this case naman, you are both precise and accurate. So accurately, kailangan ito yung tama mo, and lahat ng tama mo is close to that bullseye. So you are both accurate and precise. So that's the difference between precision and accuracy. Okay, let's proceed to the next section, which is about most probable value. So as discussed, no observation is completely free from error. Hence, the true value of an observation must be represented by a value assumed to be close to it. So this value is called the most probable value and is taken as MPV, or most probable value, equal to the summation of the measurements that will be represented by X over the number of measurements, or N. Okay, so X is the measurements, or the summation. This is the summation of the measurements, and N is the number of measurements. Wait, ilalayo ko yung iPad kasi it's stuttering. Okay, or this is just the average measurements. The most probable value is just average or mean. Next, we have the error, residual, or deviation. So the difference between an observation X and the most probable value is the deviation, okay, or the error. So that is denoted by this symbol V, that's equal to the observation minus the most probable value. Okay. Next is the standard deviation of any single observation. So when we say standard deviation, I think you are done with your statistics. The standard deviation, also called the root mean square, is a measure of spread, variation, or dispersion or scatter of a distribution. So basically, when you compute for the standard deviation tells you how scattered the responses are, or how scattered the data are. Okay, so for example, the standard deviation will now give you a hint or an idea if your precision in your measurements, because if the standard deviation is dako, that means you are katag. Okay, nag-deviate siya og dako ang imong mga measurement. Okay, so it is denoted by the symbol S sub X, and that is equal to the positive and negative value of the square root of the summation of the square of the residual divided by the number of observation minus 1. Okay, so that is standard deviation. Next sa inyong statistics. So let us note that what we use in most surveying applications is the sample standard deviation, represented by this S sub X. For most data obtained in surveying are small in size. The number of repetitions performed is far from the boundary set for it to be considered as a population. Okay, gamay raman atong obserbahan. I mean, gamay raman ta ka repetition. Okay, so the population standard deviation represented by kani sigma sub X will not be used in here. So we'll not be using sigma. Now, we have what we call the standard error of the mean. Meron din tayong probable error. So what is the standard error of the mean? Or that is called the standard deviation of the mean. It is a method used to estimate the standard deviation of a sampling distribution. It measures the accuracy with which a sample represents a population. In statistics, the deviation of the sample mean from the actual mean of the population is called the standard error. Okay, so that is simply similar to the standard deviation or the root mean square formula, pero dito mag-multiply lang tayo by n. So that is simply the sample standard deviation S sub X divided by the square root of n. The square root of n. Ayan. So that is the probable or standard error of the mean. If you are measuring the error obtained, or the calculated estimated error ng mean or the average of our measurements. Okay? Then we also have the probable error. So the probable error defines a quantity So probable error, let's denote that as PE. Defines a quantity which, when added or subtracted from the most probable value, defines a range within there is a 50% chance that the true value of the measured quantity lies inside or outside the limits thus set. Ano ibig sabihin nito? Okay, one example of this is kung naalala nyo during elections, yung mga surveys from SWS or Pulse Asia, when they are predicting who are leading in the surveys or who will be the leading senatorial or presidential. So for example, Villar garnered, let's say, 35%. Then 35%. Then sabi, the margin of error daw is positive, negative, let's say 3%. So that means it could be the probable error for this obtained measurement or obtained value could be positive 3 or negative 3. So that would be 35 plus 3 or 38, or 35 minus 3, 32. So meaning yung real value or real percentage ng boboto kay, let's say, kay Villar ranges from this. Yung 35 nasa gitna, it could be 38 or it could be up to down to 32. So for example, when you have a margin of error of 3%, and let's say the second presidential or senatorial, let's say Pacquiao got 32. So they are actually statistically tied because Pacquiao could be 35 or 29, diba? So nag-overlap siya, so they are statistically tied. Walang significance na difference masyado. Or di malaki yung difference ng dalawa. They could be tied at the same spot. So that is probable error. Now, we compute probable error this way. Okay. So, since by that definition that we have 50% chance that could lie. So, ito yung MPV. This is the most probable value. But the value could lie, depending on its normal distribution, it could lie half of 50% here or half of 50% here. So the z-score of that would be positive 0.6745 and negative 0.6745. So to get the probable error, we just need to multiply the standard error by this factor, positive or negative 0.6745. Okay? And this is the z-score for 50%. So kung gumamit ka ng table sa statistics, or maybe you just search sa Google, you just search z-score for 50% and that will give you this value. Okay? So that's it. So to continue, we'll have this formula for the probable error. So this is the probable error for single measurements and this is the probable error for the mean. Okay? So kung naalala nyo kanina, this is just the sample standard deviation formula. Then this is the sample standard deviation formula for the mean. And to get the probable error, you just multiply this by this factor, positive, negative 0.6745. So, eto na yun. Etong factor na yun. That is the z-score, 0.6745. Okay? Where, of course, P sub E, PE sub S and PE sub M are the probable error of any single measurement of a series, or sa M naman, probable error of the mean. Then this is the summation of the square of the residuals, and N is the number of observations. Okay? Then we also have relative precision or relative error. So relative precision expressed by a fraction having the magnitude of the error in the numerator and the magnitude of a measured quantity in the denominator. The numerator is reduced to unity 1. For example, your most probable error, we need to get the relative precision for, let's say, your measured value of your MPV. Lagyan na natin, ha. Let's say your MPV is, let's say, 10.05 meters. Then your error So pag-compute mo na ng probable error mo, your probable error could be 0. So let's call that probable error of the mean kasi MPV naman 0.05. Okay? So that means your relative position is your probable error 0.05 divided by your MPV 10.05. Then you express the numerator as unity or 1. So that means divide the numerator 0.05 and also the denominator by 0.05. So your answer is 1 over, mag-calculator lang ko ha. That's 1 over, wait, 10.05 divided by 0.05, that's 201. Or, i-round off na lang natin to nearest to 100, so that's 1 over 200. So your probable error is 1 over 200. Now, let's proceed to this example. For problem 1, probable error. The following values were determined in the series of tape measurements of a line. So these are the measurements: 1000.58, 1000.40, 1000.38, 1000.48, 1000.40, and 1000.46 meters. So we need to determine the following. Letter A, the most probable value, so this is the MPV of the measured length. So we need just to get the MPV. For letter B, probable error of a single measurement, so that means PES, and the probable error of the mean, the PE sub M. Then letter C, final expression for the most probable length, so that is just MPV plus the probable error of the mean, and also for individual measurements. And letter D, the relative precision of the measurement. So this is a relatively easy problem. So for letter A, we need to solve this one by like this. For letter A, we need to get the most probable value of the measurement. So madali lang naman. We know that MPV, most probable value, is just equal to the summation of the measurements over the number of measurements. So that would be 1000.58 plus 1000.40 plus 1000.38 plus 1000.46 all over, ilan yung measurements natin? That will be 1, 2, 3, 4, 5, and 6 measurements. So divided by 6. So n is 6. Okay? So using our calculator, pwede tayong gumamit ng calculator technique, but since theory pa yung discussion natin now, so iwasan mo natin yung calculator technique. That would be 1000, ito na lang. 1000 that's 1000.58 plus 1000.40 plus 1000.38 plus 1000.48 plus 1000.40 plus 1000.46 all over 6. So the MPV is 1000.45. 1000.45. This is in meters. So our most probable value is 1000.45 meters. Now for letter B, probable error of single measurement. So that would give us, ang gagawin natin, ito na lang. Let's tabulate this. Okay, so if we do this in tabular form na lang for convenience, so it would be like this. Okay, so n as our number of measurements, that would be 6 measurements. Then the summation of the observed distances or values would be the sum up of this. So just take the summation here. That would be, gamit tayo ng calculator. First, let me reverse na lang natin yung computation natin. Ayan, so 6,002.7. Okay, so the value here is 6,002.7. Okay, so the most probable value is equal to the summation of the measurements divided by n. So 6,002.7 divided by 6, so that would be 1000.45 meters. So that is our most probable value, and this is for letter A. For letter B, we need to get the probable error of the single measurements and the mean. So let's start with PE sub S. That is equal to plus minus 0.6745 times the square root of the summation of the square of the residual divided by n minus 1. So that is the that's for single measurements. So let's start first computing for the residual. So this column will be for the residual. Okay. So remember that the residual is equal to the the observed value minus the MPV, or the most probable value. So that would be this minus MPV. Okay. So 1000.58 minus 1000.45. So that would be 0.13. So the 0.13. Pwedeng ganito na lang, no? So we'll just use our calculator. Wait. So what I will do here is this. So i-variable natin yung x because that would be yung papalitan natin. So minus the MPV, which is 1000.45. So let's just calculate for 1000.58. Of course, 0.13. For 1000.40, that's negative 0.05. Then for 1000.38, that's negative 0.07. 1000.48 gihapon, that's 0.03. 1000.40, that's negative 0.05. And 1000.46, that's 0.01. Okay, then at this column we'll get the square of these residuals. So 0.13 squared, that would be 0.0169, and 0.05 squared, of course, 0.0025, as well as this 0.0025. This is 0.0049. This is 0.0009, and this is 0.0001. Okay, then you just sum up to get the summation of the square of the residual. We just need to sum this up. Okay, so gamit ulit tayo. Let's go back to our calculator. Let me zoom that. So that is 0.0169 plus 0.0025 plus 0.0049 plus 0.0009 plus 0.0025 plus 0.0001. So the answer is 0.0278. So that's the square of the residual. So therefore, let us continue the computation here. That would be plus minus 0.6745 times the square root of the square of the residual, which is 0.0278, divided by 6 minus 1, which is 5. Actually, pero diretso lang sa calculus, standard deviation niya, multiply nyo lang by 0.6745. Pero for the sake of discussion, ina-SS na lang natin. So that's square root, 0.0675, 0.6745 times the square root of 0.0278, tama ba? 278 over 5. Ayan. So the answer is 0.05029. And this is in meters. This is in meters. So up to centimeter yung gamitin natin, so that will be up to here. Okay? Ganon. Now, for letter C, the probable error of the mean, remember that is just probable error of individual measurements divided by the square root of n. Okay, so let us recall for the mean. Ito lang siya. Since probable error, nag-multiply tayo by 0.6745. Okay? So, let's just do that. That would be equal. So, yung exact lang muna yung gamitin natin, for more accuracy. 0.05029 divided by square root of 6. So, using our calculator again, handy dandy calculator. So, that's 0.05029 divided by square root of 6. So, our answer is 0.0205. That's also in meters. Now, pwede na natin i-round off na lang. Wait, ayaw mag-respond. I-round off na lang natin. So, this, let's say this is 0.05. So, up to centimeters. Dito, say 0.02. So, for letter C, letter D, yung hinahanap sa letter D, sabi, final expression pa pala, letter C. Sorry, this is not letter C, this is continuation of B. For letter C, how do we write this? That would be dito na lang. So, eto na yung mga with probable error. So, this is now the measurements, x plus minus probable error of single measurement. So, that would be 1000.58 plus minus 0.05. Kasi may, 0.05 because that is your probable error. Okay? You have 1000.40 plus minus 0.05. Let me change my pen. Okay. Then we have 1000.38 plus minus 0.05. So meaning your measurement, sa unang measurement mo, this could be 1000.63 or down to 1000.53. Ganon. Because that is your probable error for each measurement. Then your most probable value now, your MPV, could be written as 1000.45 plus minus 0.02. That's in meters. So your most probable value could be 1000.47, 1000.46, 1000.45 up to down to 1000.43. So mana ang value, ang MPV. Ayan. So, for letter C naman, relative precision. So, for relative precision, we have relative precision. That is error. So, ano ba yung error of the mean natin? That's 0.02 divided by the MPV, which is 1000.45. So, that would be 1 over 1000.45 divided by 0.02. So, let us just calculate 1000.45 divided by 0.45 at ayaw 45 divided by 0.02. So that's 50,022.5. So nearest thousands na lang, so that's 50,000. So your relative precision is 1 over 50,000. Wala siyang unit because that's the ratio. So let's proceed to letter D. So for letter D, we are asked to letter D na pala to. So this is already letter D. So letter C, ito pala yung letter C natin. Dito natin na-solve. This is our letter C. Ayan, so our answers are this. I-highlight na lang natin. So these are our answers, the MPV. And this is the probable error of the single measurements, probable error of the mean, and this is the most probable value with the probable error, and these are the measurements with the probable error. Okay, and the relative precision is 1 over 50,000. That's it. Now let us discuss about weighted observation. So here are the 3 considerations for weighted observations. So this is weight sa may letter T. Number 1, the weights are inversely proportional to the square of the corresponding probable errors. Okay, so these are actually PEs. Probable error ni siya na E. So, atong gishorten lang, atong gihimo mo na lang og E. So, weight 1 is just equal to the proportionality constant K over the square of the residual, the probable error. Okay, so that is the same as weight 2, weight 3, and weight 4 because they are inversely proportional. So, meaning weight is inversely proportional to the probable error, or pwedeng weight is inversely proportional to the probable error. Okay? So therefore, if we equate all E's here, so we could say that W sub 1 or W1 E1 squared is just equal to W2 E2 squared and equal to W3, wala dito siya, this is supposedly wala, W3 times E3 squared. Okay? Or, pwede din natin i-solve siya this way by ratio na lang of the weights and the probable errors. Number 2, the weights are also proportional to the number of observations. So, the weight of a certain measurement is proportional to the number of observations. Because, when we say weight, sabihin na natin, yan yung bigat ng measurement. Or, yun yung mas binibigyan mo ng importance sa isang measurements. Diba? So, halimbawa, you are measuring, your first trial for measuring the distance between AB, let's say AB. And, so for AB, ilang beses mo siyang inobserve, ilang beses mong tiningnan kung ano ba talaga yung measurement niya. So, let's say you observe this 4 times. Then, for your second trial, you observe again or you measured again distance AB. Yeah, for second trial, you only observed it dalawang beses. Of course, you will give much weight dun sa 4 na beses mong inobserve, di ba? Kasi yun yung mas accurate. So, you will give that much weight, more weight. So, number 3 is errors are directly proportional to the square roots of the distances. That is just similar weight, but this time error na siya. So, similar lang naman siya. Errors are directly proportional. So, errors are directly proportional. So, let's use a proportionality constant K to the square root of the distances. So, the square root of the distances. So, let's call distance as D na lang. Denote distance as D. So, yun siya. So, meaning we have E1 over square root of D1 is the same as E2 over the square root of D2. Okay, we just move this to the other side, then equate all E's. So let's try this problem. Let's call this problem 2. 4 measurements of a distance were recorded as 284.18, 284.19, 284.22, and 284.20 meters. And given weights of 1, 3, 2, and 4 respectively, determine the weighted mean. So, napakadali. Parang statistics lang. So, ang gagawin ko for more presentable solution, mag-tabulate na lang tayo. Okay. Then, this column would be the weights. So, that would be 1, 3, 2, and 4 respectively. And what would be the weighted mean? Okay, first thing we need to do is we multiply the weight and the observed measurement. Kasi para yun yung magbibigay sa kanya ng bigat. Okay? So, this would be the weighted measurement. Then we need to sum up the weighted measurements, then divide by the number of, or the total weight. So, the total weight would just be the summation of 1, 3, 2, and 4. So, that would be 4, 6, 10. 9, 10. Okay. Okay. The summation is just 10. Ibahin natin yung color for elegance. So, the total weight is 10. So, the weighted measurement, we just multiply the weights by the measurement. So, ito siya. This is obviously 284.18. Then, 284.19, let's multiply that by 3. So we'll have 852.57. Then 284.22, multiply that by 2. We have 568.44. And 284.20, you multiply that by 4. That would be 1,136.8. Then if you take the summation of that, di pa tayo kamali. Okay, take the summation of that, that's 284.18 plus 852.57 plus 568.44 plus 1136.8. So the answer is 2,841.99. So now the weighted mean, the most probable value, considering the mean, that would, considering the weight, that would be equal to 2841.99 divided by 10, which is equal to, just move the decimal place, 284.199 meters. So that's accurate up to centimeters. Millimeter. Yung third decimal place, that's already the millimeter. So this is our answer. Pwede din sabihin natin, for consistency, that's 2.84.12. No. 0.20 di. Okay. So that's our problem 2. So let's proceed to another problem. Problem 3. So this is our problem 3. The following data are the observed elevation of a point by running a line of levels over 4 different routes. It is required to determine the most probable value of the elevation. Okay? So in this case, we are given the probable error. So anyway, i-process naman natin. It could be 0.02, 0.04, 0.06 ang probable errors, pero i-express na lang siya dire as whole number. Anyway, pare-pareho rin naman yung whole number. Then if we ratio that, that would be insignificant, diba? Or ma-cancel out lang yan. So don't be confused with this na ang laki naman ng mga error. This is not 2 meters actually. This is just 2 centimeters, pero we just express that as a whole. Okay? Hindi natin tinignan yung decimal place. So let's try to answer this. So what we'll do with this is gagamitin natin to. Wait ha. So how about if I will just resize this? I'll just copy this. Oh, eto. So first we need these relations. Weight times the square of the probable error is equal to weight 2 times the square of the probable error 2. Okay? So square na lang muna natin to dito. Let's call this next column as e squared. So that would be, ato na lang i-consider this as integers ha. So that would be 4, 16, 36 and 64. Okay, that would be the square of the errors. So meaning weight 1 e1 squared is equal to weight 2 e2 squared is equal to weight 3 e3 squared is equal to weight 4 e4 squared. So that means 4 weight 1 is equal to 16 weight 2, that's equal to 36 weight 3, that's equal to 64 weight 4. So ang gagawin ko dito para iwasan ko yung decimal, although you can choose any of these values as or you can choose any of these weight as your base weight or weight 1. Pwedeng mag-assume tayo na we let W1 or weight 1 be equal to 1. Pwede din dito. But in this case, how about if I'll make na lang weight, sige, weight 4 na lang. Okay. So, if I let weight 4 equal to 1, so ito na lang yung gawin nating 1. Anyway, it will follow kahit anong weight dyan yung equal to 1 mo. You'll still arrive at the same answer. So weight 4, I'll just equate that to 1. Okay, then what would be the weight of the other trials relative to weight 4? Okay, so we'll start with yan na lang. So let's start with this relationship. So 4W1 is equal to 64W4, which is 4W1, weight 1 is equal to 64 times 1. So weight 1 would be 64 over 4. So 64 over 4, that would be 16. So yung weight 1 natin would be 16. Okay? So next relation is 16 weight 2 is equal to 64 weight 4. So I'm looking at this. So that means weight 2 is equal to, remember that weight 4 is 1. So 64 divided by 16, that will be 4. So weight 2 is 4. And weight 3 is, paano yan? 36W3, that would be equal to 64 weight 4. That's equal to 64 times 1. So W3 is just 2. Okay? Ayan. So the weight of 3 is just 2. So this is now our weights. So the next thing we'll do is we'll get the weighted weights. So again, balik tayo doon, i-multiply natin yung elevations, or that's the observed values, by the weight. Okay, so ito yung gagawin natin. So of course, unahin ko yung 1 because this is obviously 340.32. So how about 340.22 times, yung weight niya is 16, that's 5443.52. By the way, if you let weight 1 equal to 1, the values here would be mga decimal na to, which is perfectly fine. That's okay. Pareho din yung lalabas na answer dun. So next is 340.30 multiplied by its weight, which is 4. So it's 1361.20 para more precise. Then we have 340.26 multiplied by its weight, which is 2. The answer is 680.52. Okay, then we just need to add this all up to get the summation of the weighted measurements. So that's 5443.52 plus 1361.20 plus 680.52 plus 340.32. So the answer is 7,825.56. So the weighted mean now, let me write that here. The weighted mean is now equal to the summation of the weighted measurements 7825.56 divided by the total weight. So the total weight would be 16 plus 4 plus 2 plus 1, which is 23. Okay, so divided by 23. So 7825.56 divided by 23 is 340.24 kung 2 decimal places lang, meters. So this is now the weighted average or the weighted mean. That's it.